What's the horizontal asymptote of this algebraic fraction? Well, you can actually just read it off using the letters that we have, but only if you know the formula. And we're going to see exactly where that formula comes from. So you probably know that we cannot divide by 0 because then we get something that is undefined. And that's the value, so here in this case it would be minus d over c, that we have to exclude from the domain of this function. But we want to work out what value is excluded from the range of the function, because that's going to tell us the horizontal asymptote. So what we can do here, because when we find the inverse function, the domain and the range essentially swap. So the values that are excluded from the domain of the original function are excluded from the range of our inverse function. So in this case, x equals minus d over c, that could not be included in the range of the inverse. But if we find, okay, our inverse function, and we work out what has to be excluded from the domain by figuring out, the denominator, what makes the denominator 0, that's going to be the horizontal asymptote of this original function. So we can go ahead and do that. So to find the inverse function, we swap our variables around, and now we want to make y the subject. So we get xcy plus dx equals ay plus b. And then we want to put all the y's on the same side. So we get xcy minus ay is equal to b minus dx. Factor out the y, so y, and then we get c x minus a is equal to b minus dx. So y is equal to b minus dx over cx minus a. And this is our inverse function. So the inverse of f is b minus dx over cx minus a. So the thing that makes the denominator 0 here, well, that is when x is equal to a over c. So this is our formula. All we have to do is just look at the coefficients of the x terms on the numerator and the denominator, and just do the numerator coefficient of x divided by the denominator coefficient of x. And that is the value that gets excluded from the range of our original function, and thus that is what the horizontal asymptote is. If you like that, drop me a follow.